So our determinant should be 5. So one way we can write this is I can just put the 1/5 out front, knowing I'm going to distribute it later. Flip my a and d values so that I have a 1 and 2. Change the signs in front of my b and c values. So this would be a positive 3 and a negative 1. That would be fine for the solution. Or we can distribute the 1/5 in. So we can write this as 1 over 5, 3 over 5, negative 1 over 5, and 2 over 5. So most of the time, either one of these would be an acceptable answer. However, the bell work had the 1/5 pulled out, so we'd have to find the one that's 1, 3, negative 1, 2, and that would just be that A with the 1/5. Okay? And I kind of had a trick in here, because if you didn't realize it was a negative, you actually would have got a negative 1 out for B. So just be careful with your negatives and you write slowly. All right, that is our bell work. Do we have any questions from the old homework, as they say? Go.
Can you just do the entirety of 14?
The entirety of 14. Well, the entirety is pretty quick, because on number 14, we just calculated a determinant first. Our determinant would be, our a value is negative 1, so we'd have negative 1. Our d value is negative 10. And we would subtract our b value is 5 times that 2. This would be a positive 10. This would be a positive 10, which equals 0. D is not allowed to be 0, so you just can't, there's no inverse. Just no inverse at that stage. That's why I say find your determinant first before you start swapping around stuff, because you might not have to do that. Yeah?
If we just circle the D to the right equals 0 with that one, or do we have to say?
Nope, that's good. Just do something that I know you're done. This will tell me you're done. Don't just like, oh, I don't know what to do next. Let me know that you know that means that you can't go any further. All right, other questions from the homework at all? Okay, so yesterday was important for today. Because today we're going to solve systems with inverses. When we're solving systems using inverses, we're going to use matrices. Now, the first time we use matrices to solve systems equations, we use Gaussian elimination. Gaussian elimination, it basically set us up with where you had to have that augmented matrix. I don't know if I need to put that. Where we have to use that augmented matrix. So for Gaussian elimination, if you remember, this was the Gaussian version. Gaussian would look something like this. No, that's not a matrix symbol. It would look something like this, where we have A, B, C, D, and we'd have kind of like E, F over here. That's if we were using Gaussian elimination. We're not doing Gaussian elimination this time. We will not use augmented matrix. In fact, we're going to use matrix multiplication to replicate these systems. So Gaussian elimination, the first thing we did this. For inverses, we're going to set something up that looks like this. And I pulled this from our previous lesson where we had something that would look like this, where we'd have like an A, B, C, D matrix. We'd have a matrix that houses our variables, and we'll have a matrix that houses our constants. So each of these have their own matrix. This right here is the exact same thing as these systems up here. We did this as part of a lesson. We did this as part of a homework. When you would actually multiply, I'm not actually going to multiply them, I'm just emulating it. If I'd actually multiply these out, I would have AX plus BY. Well, that's what I wanted. And if I took this row times X and Y, I'd have CX plus DY, which would be this. Oop, I didn't actually want to erase. Let's go backwards. So this is the way we're going to set up this system of equation in matrices for inverses. So this is going to be important because on the test, I'm going to say use Gaussian elimination to do it, and then I'll say use inverses to do it. You need to know how to set it up. So if I say Gaussian elimination, we use an augmented matrix. If I say use inverses, we set it up like this. All right, now we have this. I don't want to keep writing these matrices over and over and over to show stuff, so I'm going to let some variables represent what they are. I'm going to let cap A stand for the matrix with the coefficients. I'm going to let cap X stand for the one with the variables, and I'll let cap B stand for my E and F. So when I talk about those, you know what matrix I'm talking about. So currently we have this setup. We have matrix A times matrix B equals our constants. I don't want this when I'm done. It's kind of like, let's say I had 3x equals 6. How do I solve for x? Yeah. You divide by 3. Now, we can't think of division because you can't divide matrices. Did we have a lesson on dividing matrices? No, because we don't do that. But there is a way to get rid of a matrix, in other words, to move it to the other side. And that is inverses. Inverses, so even what Caroline said, she actually used an inverse. She basically multiplied by 1 over 6. It just looks like a division, but it is multiplied by 1 over 6 because multiplication and division are inverses. You take the inverse of 6, which moves it to the other side and replaces it with a 1. Well, we learned yesterday that we can multiply a matrix by its inverse. So our next step is actually to multiply both sides by the inverse of this matrix. So I will then have A inverse times A equals, I'm going to make a mistake. And you might not see it at first, but this is actually a big mistake that people are going to make. It feels right. I multiply both sides by A inverse of A. There is a mistake on this side. Can anyone pick out what the mistake is? Yeah. Why?
Because, like, it changes if you switch the order of multiplication.
Not only does it change it, this is actually not, you can't multiply this. Because what's the size of matrix B? It is a 2 by 1. What's the size of matrix A? 2 by 2, which would also be our matrix here. So this would not work. You can't do this. So just like Leo said, you have to be very careful on what side you multiply things on. It has to be A inverse times B. You do it out of order and you can't even do the multiplication. Like Leo said, even if you could do the multiplication, it's a different answer. So we have to keep it out front. What happens when I multiply a matrix by its inverse? What's guaranteed to happen if I multiply a matrix by its inverse? What's the result? Yeah. It would turn into the identity matrix. And what's the identity matrix? Yeah. It's equal to 1 in matrix world. So this is basically going to cancel out because this is going to be the identity. That's the identity matrix, which in matrix world is just 1. I have 1 times x equals this, which I should be able to do the multiplication of. So let's come down here and just shortcut this without having all the steps of what we're actually doing here. So if I give you does anyone need that up? I'm sorry. Are we good? Okay. So if I give you a system of equations like I have up above, I have that ax plus by equals e over this. What we're picturing is this matrix here. I'm picturing, I can turn this into AB, CD, multiplied by x, y, equals E, F. Then we're going to do some math yoga. In that math yoga, we're going to find the inverse. We're going to multiply that inverse on both sides. And we're going to result in something that looks like this, that we have x over y equals, and making sure we put the inverse first, we're going to have a, b, c, d, but we're going to put the little inverse symbol up there to say, okay, it's not actually a, b, c, d, it's inverse, multiplied by e and f. Now, x and y are variables. Everything else is a number. So we're going to do this multiplication. We're going to solve the problem. So we don't actually have to turn it back into equations like we've done before. We can actually solve it by just multiplying these numbers by its inverse. All right, let's do all of that from step 1 till the end. And then I'll show you on the homework the stuff I need to see. You can do all of the steps on your homework, but there's specific steps I need to see on your homework so I know that you did it properly. All right, but this will be every single step. So if I tell you to solve using inverses, you know you're not using an augmented matrix. Augmented matrix have that straight up and down line, and it's just one matrix. When we're setting up matrices for inverses, we're going to set it up as 3 different matrices. We'll set up a matrix with the 3, -2, 2, and 1. In other words, the coefficients. We'll have a matrix for our variables. That'll be x and y. And we will have a matrix with our 4 and -3. And if you ever doubt yourself that you set it up right, just do your multiplications. Row times column will say, okay, I have 3x minus 2y. Let's play devil's advocate for just a second. Let's say I have x's and y's flipped. I have my x's and y's here. I have -2y plus 3x. I have y plus 2x, and I don't rewrite these equations. What's the only thing that changes on here? Yeah. We would have to do the y over x. We have to move a little bit of the numbers. But you basically do the variable that comes first goes on top. So be careful about that. All right, and now we're going to find the inverse of the matrix. Now, when I say the inverse of the matrix, there's only one inverse we can find, and that's our 2 by 2, which is a square matrix. So we're going to find the inverse of that 3, -2, 2, and 1. So the first thing we're going to do is we're going to find the determinant. So let's find our d value first. That is our a value, 3, times our d value, which is 1. We are subtracting our b value times our c value. That's going to equal 3 plus 4, which equals 7. So I can definitely find the inverse. Remember, if this is 0, we can't. Just like Peyton said, we can just put d cannot equal 0. I'm done. All right, to do our inverse, let's just call it a inverse. Yeah, I just want to make sure I didn't miss anything along the way. Okay. So writing our inverse, remember there's 2 ways to write our inverse. We can use, I'm just going to call it A inverse equals, I like to have something out in front. We can put this as 1 over 7 first and then do the matrix, which we switch our A and D values, so that's 1 and 3. Switch the sign, so this would be 2 and -2. That's one way we can write it. The other way we can do that full multiplying, put everything over 7. So we could leave this as 1 over 7, 2 over 7, -2 over 7, 3 over 7. Both are acceptable, yeah. Oh, sorry. Yeah, both are acceptable. If you're good with fractions, you'll notice on my answer key, I basically just use that. I can do my multiplications fine. I'm assuming some of us don't like using fractions as much. If you're in that camp, just leave it like this because we're going to do a multiplication. And sometimes it's easier to do a multiplication with this than having fractions where you have to keep the thing. So for this example in class, I'm going to cater to the people that might not like fractions, and I'm going to stick to using this one. So I'm going to stick to using this one the rest of the way. And I'll show you how to use it. It's nice to know how to use that version. All right, the next thing we're supposed to do is we're supposed to multiply both sides by the inverse. Now, be careful. We need this to be in front, and this also needs to be in the front. You can't stick it after because then you can't do the multiplication. So this needs to go here, and this needs to go right there. I'm going to cheat because I can't quite see up here. So I'm going to come down here. I do know I have my 1 over 7. So let's try to do that. I got my 1 over 7. I got my inverse. Maybe I'll put my inverses in a different color. Let's put them in orange. So these are the inverses I'm multiplying both sides by. I'm sticking with the 1 over 7. I got my 1, 2, negative 2, 3. The one that was already there was our 3, negative 2, 2, 1. And we also had times x over y. On the other side, we're going to put our inverse, which was that 1 over 7, 1, 2, negative 2, 3. And what was already over there was our constants of 4 and negative 3. All right, the first thing I want to recognize is a matrix times its inverse equals the identity matrix, or 1. So in fact, what we're trying to do is we're trying to cancel out the matrix from this side. And so all of this is the identity, which just equals 1. So I'm going to come down here and say, already have my left side done. My left side is already just x over y. I'm done with that side. That turns into 1. Just have 1 in front of that. This side, I have to do the multiplications. What do you think I'd do with that 1/7 out front? How do I do this multiplication and account for that 1/7? Mira? Yep, we're going to pretend that doesn't exist for a second. We're just going to multiply these matrices, get a new matrix, and then plug in that 1 over 7 after. So we're going to first do our multiplication. So remember, that's row times column. I should have checked. I'm going a little too fast. I should have checked that I can do the multiplication. That is a 2 by 2. This is a 2 by 1. I can do the multiplication, and it should result in a 2 by 1 matrix. All right, now row times column. We're going to have the 1/7 out front, so I'm going to leave that out there. In the matrix, I'm going to have 1 times 4, which is 4. 2 times a negative 3, which is a negative 6. Then we'll move to the next row. Remember, you write as much as you need to write. I'm just going to kind of do stuff in my head. I have negative 2 times 4, which is a negative 8. I have 3 times a negative 3, which is a negative 9. Which is going to equal 1 over 7 times negative 2 over negative 17. Did I make any mistakes along the way, or did someone? I'm good? All right, now we have to distribute that 1/7 to both of these. So really this is negative 2 over 7. This is regular negative 17 over 7. I'm just going to write that down here. So I'm going to do that in this step. So we're going to have x over y equals negative 2 over 7. And I'll have negative 17 over, nope, hang on. Yeah, negative 17 over 7. There we go. Why is this problem not finished? Cozy.
You need to do the x equals y.
Absolutely. I need the x equals and the y equals to complete it. So I have x equals a negative 2 over 7. And I have y equals negative 17 over 7, and now we are done. All right, mathematically, it's not overly complicated. It's just a lot of little steps, finding the correct matrix, understanding that it has to go on a certain side. So keeping all that in mind, I want to see some specific things on your answer key, and I'll point out what I need to see on your homework when I'm checking it tomorrow. Tomorrow, I do need to see a couple different things. You might not have to show all the work I did. Here's what I need to see. I need to see the matrix, the one we're creating the inverse of. I need to see the inverse of it. And most of the time, I need to see at least a little bit of work. At the very least, that I see that you calculated the determinant, not that you plugged in your calculator and got the inverse that way. So I need your matrix, some idea that I know that you did this by hand. You created the inverse. I need to see this equation. I need to see x over y equals the inverse times that negative 3 over negative 6. and then I need to see x equals something and y equals something. So once again, I'm showing a little bit more on here, but I just need to see the matrix, your inverse. I need to see this equation. And then at the end, I need to see x equals and y equals. Obviously, you can put as much work in there as you want, but at the bare minimum, I need to see that stuff. Is there any questions about what I'm looking for tomorrow for the answer? Basically, you can do this stuff in your calculator. And if you want to practice that at home, you can. We'll go over it tomorrow, how to do this in your calculator. And I do not want us just to plug these in our calculator and get an answer. So I'm making sure I can see all of the steps. I will do the same thing on your test. On your test, you're going to have to show me those same steps, so you're not just plugging in your calculator. That I know you can do it by hand if necessary. All right, questions on any of that? All right, that is